Lekazir anober mai Lekazir anober mai Lekazir anober mai kan triat ngai lo le zir ngai lo te po kan hu lo le kan cho ngai lo te po izir zelang so turin izir zelang so turin lekazir anober mai lekazir anober mai lekazir anober mai. Hello guys, and so today we are going to do another application of dimensional analysis, the third application, which is conversion of one system of units to another using dimensional analysis. So you can see conversion from one system to another using dimensional analysis. This is the third uses of dimensional analysis. So here we have a problem. Now we are going to convert a velocity of 36 kilometer per hour into meter per second. So this value is in kilometer per hour, a bigger unit into the SI unit or smaller unit, meter per second. Okay, this is kilometer per hour, so we have to express in meter per second. So how to do with the help of dimension analysis? Let me show you first the common way, or in a real life situation in everyday we use to convert like this first, then I shall show you how to do in dimension analysis. So solution like this, solution. Okay, what is the convert a velocity of 36 km per hour into meter per second? So here we have, here velocity is 36 kilometer per hour. Okay, 36 kilometer per hour, and we know that now 1 kilometer equals, we know that 1000 meter, isn't it? 1000 meter, and 1 hour equals 60 into 60 second. 3600 second. Okay, now let's write like this: velocity equal to 36 kilometer per hour. Here 36 into 1 kilometer into 1 per hour. So like this, 36 into 1 kilometer is 1000 meter. 1 hour, 1 hour, this is 1 hour. Put this outside. Okay, per 1 hour is 3600 second, minus to the power minus 1. Okay, so 36 into 1000, then 36, since it is to the power minus 1, it comes down. 3600, this is meter and this is second. Okay, so cancel the two zeros, and 36, what is left is 10, and unit is meter per second. Therefore now we convert a velocity of 30 km per hour into 10 meter per second. So this is the answer. So we usually apply like this. It is very simple in real life. However, there is another way, like with the help of dimensional analysis. So we are going to do this same problem with the help of dimensional analysis. Okay, dimensional analysis. Let me first explain the general formula. Okay, the general formula, you can look it here. General formula. So we know that in chapter 2, unit for measurement, the unknown physical quantity is equal to Nu, where N stand for the numerical value of physical quantity and U stand for size of the unit. And when there are two unknown quantities to compare like this, we put like this: N1 U1 equal to N2 U2, and then put the dimensional formula like this: M1 A L1 B T1 C. Here we compare, and when we put like this, so this is the general formula. Okay, this is the general formula to find out or to convert one system of unit to another with the help of dimensional analysis. So you look carefully, you look clearly. Okay, let me show you clearly. This is the dimensional general formula. So we are going to use this, okay, and solve the same problem. Okay, now we shall solve the same problem. So let's write dimensional formula, general formula: N2 equal to N1 M1 by M2 A L1 by L2 B T1 by T2 C. So this is the general formula. Now we are going to find out the same equations. That means 36 kilometer per hour into meter per second. How do we do? Okay, now this solution. Here N1 is equal to, this is the 36, and do we have M mass? We don't have mass in this equation, no mass. Okay, meter, this is meter, not mass. Kilometer, meter. Kilometer is a distance, hour is a time. There is no mass, so we don't have M. So let's take L1 equal to 1 kilometer, bigger value, and time, what is the bigger value here? 1 hour. Okay, and what about the unknown quantity for the smaller unit? N2, what we are going to find is N2. We are going to find out N2, and L2 is 1 meter. Okay, L2 is 1 meter, and T2 is, we have to express in second. So 1 second, T2 is second. It's like this. So okay, now we are going to write like this: N2 equal to N, let's put it directly. Okay, N2 is 36. Sorry, N2 is N2, N1 is 36, then M1, M2, here we simply write because its power, okay, let's put it, its power is A. L1 is, what about L1? 1 kilometer, 1 meter, its power is B. t1 by t2, 1 hour, 1 second. Its power is c. Okay, and now let's write what is the time. This is actually, you must know that what is kilometer per hour. Kilometer per hour. Kilometer per hour. Okay, now 36. We don't have mass. Okay, we don't have mass, so we know that what is distance by time is velocity, isn't it? Velocity is distance by time. Okay, distance by time. This is velocity. Distance by time, it's distance by time we don't have. That means its dimensional formula is -1. Here if we compare dimensional formula, so m will be equal to 0, l equal to 1, t equal to -1. So here a, if we compare this, it will be 0, m0. B, what is b? This b, here we have 1, and what is c? Here we have -1. Okay, here it's 3. AB, now we get ABC. Now put the value, n2 equal to 36, m1 by m2 to the power 0, 1 kilometer by 1 meter to the power 1, because b is 1, and 1 hour by 1 second to the power -1, because c is -1. Okay, because c is -1. And then I shall continue here. C is -1, n2 36, n2 equals to 36. Here anything to the power 0 is 1, isn't it? So we may discard this because it is only 1. So 1 kilometer, what is 1 kilometer? 1 kilometer becomes 1000 meters, isn't it? 1000 meter. Then 1 meter, you write like this. And 1 hour, 60 into, you must convert it into second. So 1 hour equal to 60 into 60, 3600 second, 3600. 3600 divided by this second, this 1 second to the power 1. Okay, 36 into 1000, 3600 to the power -1 unit. Let's write unit here. Okay, 36 into 1000 is to the power, you can see that is to the power -1. So we shall put it down, and this unit. Let's write unit, and now cancel this 2, this is 1. That means now it comes out to be 10 unit. What is the unit? Unit is meter, and here second we have meter. Meter per second is the unit. So instead of unit, you can write meter per second. So we convert the bigger unit, kilometer an hour, into meter and second. So now we get the unknown value is 10 meter per second. So this is how we convert one system of unit to another system with the help of dimensional analysis. Okay, let's do another problem. This is proof that 1 joule equal to 10 to the power 7 arc. Okay, joule is a bigger unit of work and arc is a smaller unit of work. So we are going to prove with the help of dimensional analysis. Okay, so let's go directly. So in the bigger unit we have M equal to 1 kg. We have to write like this. Okay, L1 equal to 1 meter, time equal to 1 second. Okay, isn't it? And what is N1? N1 here is 1 joule. Okay, and M2 for the smaller unit, M2 1 gram, L2 1 centimeter, T2 is 1 second. And what about N2? N2 in any, yeah? So we are going to find it out. This, let's put a question mark. Okay, so now we know the general formula. Let's write N2 equal to N1 M1 by M2 A L1 by L2 B T1 by T2 to the power C. Okay, so ABC, this is the general formula. Okay, so now in the next, let's find out the dimension of work, because this is work unit. Okay, so we shall find out the dimensional formula of work, then compare the power of the dimensions, and it's this ABC. Okay, it's power ABC. Now what is the dimension of work? Dimension of work is M L square T minus 2. Okay, now compare these two. Here A and this B and this L. Okay, so A will be equal to 1, B will be equal to 2, and what is C? C will be equal to minus 2. Okay, so you can see like this. C here, my minus 2 is minus 2 for B, this C minus 2, and B2 and A1. Okay, so this is very important. Now let's put the value in this general equation. N1 is 1. Okay, here 1. So N1 is 1, and into, what about M1? M1 is 1 kg, and M2 is 1 gram, and L1 1 meter, and L2 1 centimeter, and so on. Likewise we are going to put the value of M1 1 kg by 1 gram, and its power A is 1 meter by 1 centimeter, since L1 is 1 meter, L2 is 1 centimeter, and its power B is 2, and time 1 second, and its power C is minus 2. Okay, like this. Now no need to write 1. So 1 kg equals how many gram? 1000 grams, isn't it? 1000 gram by 1 gram, and there is only the power is 1, and here 1 meter equals 100 centimeter, isn't it? So 100, put 100 centimeter by 1 centimeter, and its power is 2. Don't forget to write its power 2. And second, 1 by second, same, isn't it? 1 minus 2, that's the right second. Now take only the value outside, unit G and G same, centimeter and centimeter. So 1000 here, 100, you know that this is square, 1 second is 1, okay. Minus 2, no need to put second. So it's like this: gram, centimeter square, and second square. Okay, this is the unit. Now 1000 into 100 square is 10,000. 4 zeros, isn't it? So anything to the power 1 is 1. Okay, so into 1 gram centimeter square per second square. So how many zeros here? 1 2 3 4 5 6 7. So 10 to the power 7 into 1 is 10 to the power 7. So this unit is gram centimeter square per second square is smaller unit of work, which is arc. Okay, so therefore we get the unknown value n2 10 to the power 7. If we put its unit, then arc. Okay, so now we have proof that 1 joule equals 10 to the power 7 arc with the help of dimensional analysis. So dimensional analysis is very, very helpful to solve this kind of problem. Okay, so you can do the other example from your textbook. There are many examples in your textbook. Okay, so try to do some exercise at home. So that's all for today.